Welcome to Linear Models. So I gave you a little information about me in that introduction video. If you haven't watched it yet, go ahead and watch that, and then make sure that you introduce yourself on Canvas so we can all get to know each other as this class is beginning. But just so you have it all in one place, here is my email address, mcgowld@wfu.edu. Please use Canvas to post most of your questions about this class in the discussion forum so that we can all kind of equally contribute to those, and in case anybody else has the same question, it can be answered in one place. But if you have a personal question or a question about grade, feel free to email me those. And I'm going to be offering office hours again on Tuesday, Thursday from 9:30 to 10:45 and 12:30 to 1:45. And there are two ways you can do those. The first is via Canvas chat. And so for that, you'll just log in to Canvas at those times, and I'll be monitoring those chat feeds. And the other way to join my office hours is via a 15-minute video Zoom session on a specific topic. And so if you'd like to do that, you can find the topics lists under the office hours discussion thread. And if you don't see one already listed, you can go ahead and book one and make sure to list it there so anybody else that might be interested in joining can join us as well. All right, so everything you need is going to be posted on this website, bit.ly/STA312F20. And as I mentioned in the Canvas walkthrough, while everything is going to be hosted on this website, so you can go to this website to find all the different links, I'm also going to be creating basically to-do lists in Canvas. So you can just go to Canvas as kind of your one-stop shop to click through what you need to be doing before class, during class, and after class, and it'll take you to the appropriate links on the website. So this website is going to be where everything is hosted, but you can really focus on Canvas as your primary place to get information about this class. Okay, so here are some quotes about statistics. So the first is, "Truth is much too complicated to allow for anything but approximations," by John von Neumann. And so I think that's a kind of great segue into thinking about what we're going to be talking about in linear models, basically how we're going to be trying to make these approximations, how we can make them in the best way possible, how we can minimize our error, and things like that. Here's another one. "Statistics is using data and knowledge about randomness to condense, communicate, and contextualize information and provide insight into the setting from which the data came." So that's from Joe Hardin, who's a professor at Pomona. And then finally, this is a very common one that I'm sure you've heard before: "All models are wrong, but some are useful," by George Box. And so in this class, if you took 212 with me, some of this will look sort of familiar, but all of you, I believe, have taken 212 at some point. And basically, these principles are the same ones that we talked about in 212, but we're going to be sort of building on in a much more theoretical framework in this class. So we're going to be talking about these wrong models and how to make them more useful. So this is the general framework that we're working in, particularly in the linear model space. We've got data equals model plus some error. And so in math speak, it's something like this. You've got y is a function of x plus some error term. And so that function of x is your model, and x is the data used to build the model. Y is the data, the outcome that you're trying to estimate. And the easiest way to do this is via a simple linear regression. So again, this is how we're going to start in this class. This will look a lot like your 212 background, just with simple linear regression, except now instead of just kind of telling you this is how it is, we're going to be able to prove together why this is a sensible thing to do and how to actually estimate these coefficients mathematically. Instead of sort of just giving you the answer out of the box, you'll be able to derive them yourself. Okay, so let's do a quick example. This is Bob Ross at an easel. And so just to sort of motivate this linear regression type problem, I got some data from 538, and on the x-axis, I plotted the season, the episode season for the Bob Ross's painting show, and on the y-axis, I looked at the number of paintings that had clouds. And so if I fit a linear model, a simple linear model to this, it would look something like this, where it looks like the beta coefficient for beta 1 is going to be positive. That is, the slope is positive, so there's a positive relationship between, as the seasons go on, the number of paintings with clouds increase. And so in this class, we're going to be talking about exactly how to fit this line, why this line is the best line for these particular data points, given the information we have given this model so far. And we're also going to talk about how to estimate that variance, the standard error, that shaded region, and what that means exactly. So this is that simple linear model here that blue line represents that beta 0 plus beta 1x. So the number of paintings with clouds, the y-axis equals beta 0 plus beta 1 season plus epsilon. But what if it looked something like this? If I include more seasons, and so if I don't cut off the axis, if you notice here, the x-axis has increased. So originally I cut it off around 15. But if I go all the way to 30, we have a very different picture. And so now we've got some function of season instead of including just the season itself. We've got some kind of nonlinear function. So we're going to be talking about how to kind of fit these types of nonlinear functions as well in this setting. And then, of course, we'll get into multiple linear regression where we add even more complex terms and extend the theory behind them. So this class is going to feel a lot like basically building on the 212 class that you already took, except we're going to be inserting a lot of theory and a lot of proofs kind of into that estimation framework so that you can really understand where these estimates come from and why they make a lot of sense to do in certain settings. Okay, so let's go. That's sort of an overview of what is going on here. Now we're going to do a quick exercise together. So the first thing I want you to do is log into RStudio Pro. And so for this class, we're going to be using RStudio Pro to be able to use RStudio, which is the interface we're going to use to be able to run code in R. And so I want you to be able to both, in addition to kind of getting this very strong theoretical grounding, I want you to be able to immediately apply those concepts to real-world data. And to do that, we're going to use R. And so to get into RStudio Pro, you're going to need to use VPN, a VPN to connect. And so go ahead and get that set up. You can do that through Wake. If you just Google VPN WFU, you should be able to find it. Or if you go to the slides for today, you can click on this link I have right here to get your VPN set up. And once you've done that, you can click on this link, rstudio.hpc ar53.wfu.edu:8787, and that will bring you to our RStudio server. Your username is going to be your Wake Forest username, which is typically the first part of your email, and the password is R2D2 star. So while you're doing that, I'm going to do it as well so you can see what it looks like. And so when you go to this URL, rstudio.hpc.ar53.wfu.edu:8787, you should come up to this screen to sign in. So I'm going to sign in with my username, McGow-LD, and the password is capital R, 2, capital D, 2, capital S, T, A, R, exclamation point. All right, so when you sign in, depending on if you've used this before, RStudio Pro or not, you may see this screen where you get to basically a main screen here. This is what RStudio looks like, and this is what it looks like on the server. It looks the same. So you may see this. If this is what you see, go ahead and click on this blue RStudio server home icon. Or alternatively, if this is your first time joining RStudio Server Pro, you may see something like this. And so we should all be back at this place now. So if you don't see this kind of main screen version, go ahead and click that blue circle at the top there of your RStudio session. And what I want you to do is I want you to look in this projects, and I want you to find a project called 01-welcome-penguins, and I want you to click that. And that's going to open this up. And that should bring you to this session where you can continue on with the instructions on the next slide. Okay, so hopefully you've all logged into RStudio Pro. Go ahead and pause the video if you haven't yet and get that sorted out. I've put on Canvas in your what to do after this class. I've put a little assessment to just check a box to let me know if you got all set up in RStudio Pro. And if you're having any problems, I've got a space for you to add comments so that we can try to troubleshoot that together. We're going to need RStudio Pro for a lot of the exercises we're doing, in particular the way that I'm going to be doing labs in this class. You need to have access to this so that we can collaborate across students. So make sure that you've got this set up. You don't want to just use RStudio on your local computer because we want to have that ability to collaborate across students. Okay, so once you've logged into RStudio Pro, find that project O1 Welcome Penguins and click it. And then in the Files pane in the bottom right corner, you should see a file called welcomepenguins.rmd. I want you to open it, and then I want you to click on the knit button. See if you can find the knit button yourself. It's going to be somewhere along the top. And then I want you to go back to the file, and I want you to change your name on the top in the YAML, which is something we'll talk about what this means later. And then I want you to knit it again. And then scroll to the plot chunk below the title Palmer Penguins and do some code editing. So instead of looking at the relationship between flipper length and bill length, I want you to plot the relationship between flipper length and bill depth. I've included a full data set at the bottom of the document for variable names, and so once you've knit that file, you can look through that data set at the bottom to be able to decide kind of what variable names you should be using for this new plot that I'm asking you to make. I'd like for you to also update the captions to match your new plot and to knit it again. So this should take about 5 minutes. I'm going to go ahead and set that timer. You can go work on that. If you need more time, of course, you can just pause the video.